Hello, welcome to this video 3-5 part B on related rates. In this video we are going to look at two contextual examples and we are going to be using our procedure for related rate problems, these 5 steps. So if you ever are confused about these problems, we're going to be using these to help kind of guide us through these examples. All right, so without further ado, here is the first example, and it says a windlass is used to tow a boat to a dock. Okay, so we have a windlass, which is here, tying a boat to a dock. The rope is attached to the boat at a point of 15 feet below the level of the windlass. Okay, so we have a rope, which is here. Okay, and it's attached to a point at a point 15 feet below. Okay, at a point 15 feet below level of the windlass. Okay, and that is this information here. Okay, so the 15 feet, and all of that is given. It says if the windlass pulls the rope at a rate of 30 feet per minute, at what rate is the boat approaching the dock when there is 25 feet of rope out? Write a sentence explaining the meaning of the answer. Okay, so they give us some information here, and we want to go ahead and organize it. Okay, so in related rate problems, you want to ask yourself, okay, what's changing here? Okay, and they say that the rope is it's being pulled at a rate of 30 feet per minute. Okay, so here's your rope, and it's being pulled this direction. Okay, so when it changes, right, that is dz with respect to time, and dz dt is 30 feet per minute. Okay, so I have my figure, right? This is step 1, figures given. Step 2, I'm going to start just writing down all the information that they give us. Okay, so dz dt is equal to 30 feet per minute. All right. They want to know at what rate is the boat approaching the dock when there is 25 feet of rope out. Okay, so when there is 25 feet of rope. Okay, well, rope is equal to z. Okay, so I also know that z is equal to 25 feet. Okay, and they want to know, here's the question, this is always important. It says, what rate is the boat approaching the dock? Okay, so here's the boat, right? And it's approaching the dock. It's going this direction. Okay, so that is dx dt. And it's also important to note too that this distance approaching the dock is shrinking. It's a negative distance. And then also the same here with dz dt. Okay, so that's a negative 30 feet per minute. All right. Okay, so I have my given information. I want to find out, the problem is asking about dx dt. We want to know this. Okay, and I want to go ahead and solve this. So let's go back to our problem steps. We have drawn a figure. We have write what is given and is to be found with our differentiation symbols. Okay, and now we need to write an equation of the relating variables. So note, sorry, I went too far. Okay, note that this is a right triangle, and with right triangles, generally we're going to be using what theorem? Okay, Pythagorean theorem, very good. Okay, so step 3, here's the equation that kind of ties it all together, right? Is a squared plus b squared equals c squared. Well, I don't have a squared and b squared and c squared. What I have is I have 15 feet squared. Okay, plus my b, which is x, so this is, sorry, x squared. Okay, plus c squared, which is my rope, or z squared. Okay, so here is my formula that ties all of these variables together. Sorry, not equals, that should be, or plus, that should be equals. Okay, so now that I have my formula tying all of these together, what we want to do is now do step 4. So implicitly differentiate both sides with respect to t. So I'm going to take my formula and I'm going to differentiate. Well, the derivative of a constant is 0. So I have 2x times the derivative of x, so dx dt, which is equal to 2z times dz dt. Okay, so it looks like a bunch of gibberish here, okay? But what we're going to go ahead and do here at this stage is we are going to substitute. Okay, so I'm going to plug in values and quantities that I know. Now, it's important to note dx dt, this is what I want to solve for. I want to isolate this, okay? And I don't have an x. This is missing. I don't have an x, so we'll have to go ahead and calculate that. Do I have a z? Well, yeah. Remember when we want to find the rate, right? Z is equal to 25. Okay, so I can plug that in. And then dz dt. Do I have dz dt? Well, I sure do. Isn't that 30 feet per minute? The boat is changing at that rate. Okay, so what we're going to go ahead and do is a couple things. We're just going to go ahead and substitute in all these values. So we have 2 times x, which we don't have. Dx dt is equal to 2 times z, which is 25. And at this stage, I'm going to start using my units too, so that's 25 feet. And times dz dt, which is 30 feet per minute. Okay, so I want to find x. Is there a way I can find x? Well, sure. Don't I know that 15 squared plus x squared is equal to z squared? Well, and at this time, z is, the rope is 25 feet. Okay, so we can go ahead and solve this. So what we get is 225 plus x squared is equal to 625. So x squared is equal to 400. So x is equal to plus or minus 20, but in this case context, we only want 20 feet. Okay, so that's 20 feet. All right, and now we can go ahead and plug this in. So 20 feet. All right, now if I want to solve for dx dt, all I'm going to go ahead and do is divide both sides by 2 times 20, which is 40. So dx dt is equal to 2 times 25 feet times 30 feet per minute. Okay, all divided by 2 times 20 feet. So that is a numerical answer, and that would be your answer. But for these sakes and purposes, we want to go ahead and kind of simplify this. So unit-wise, the feet cancel, and if you plug this into your calculator, you should get negative 37.5 feet per minute. And you're like, Schwarberg, where did the negative come from? I am so sorry. I forgot my negatives. This 30 is a negative, and I should have put that back up here when I denoted it right here. Okay, so that's going to make our numerator negative, which will give us a negative answer, negative 37.5 feet per minute. Now, the problem says, write a sentence explaining the meaning of the answer. Well, I mean, what was the question? The question says, if the windlass pulls in a rope at a rate of 30 feet per minute, what is the rate? What rate is the boat approaching the dock when there's 25 feet of rope out? And we're just going to go ahead and we're going to write this sentence and express that. Okay, so we can say, when there is 25 feet of rope out, The boat is approaching the dock. At a rate of negative 37.5 feet per minute. All right, and there is your answer. Okay, so I'm gonna go ahead, since we're at 10 minutes, I'm gonna pause this video. I'm gonna make a third video with the next example. All right, catch you next time.